Dear students, now let us look at the cycle service level approach. In many cases, short-run demand is variable, even though long-run demand is assumed constant. It can happen that for an enterprise, for some period of time, the demand is not that constant, or the assumption that we have taken before, that for such kind of products, the demand could be assumed constant. But it may happen that for some period of time, the demand would not be that constant, or there would be more variation in demand than usual. So therefore, stockout events during lead time may occur unexpectedly in each cycle. So there are chances that your distribution for such kind of a product would not be that symmetric. And when there would be a skewness in your distribution, let's say it is normally distributed but with some skewness, then what will happen? You will see more often than not the stockouts. So stockouts occur only if demand during lead time is greater than the reorder point. Yes, this is the main simple logic behind the stockout, that if your demand during the lead time is greater than the reorder point, the safety stock or the critical level which you have taken, so what will happen? You will see the stockout. So to determine the reorder point, we need to know two important facts: the lead time demand distribution. The second thing would be the required service level or the targeted service level by that enterprise. So in many cases, lead time demand approximately normally distributed, yes, that we have seen. One can argue that, but for most of the inventory systems or most of the inventory management control systems, normal distribution is a very plausible distribution assumption. For the normal distribution case, the reorder point is calculated by, so what we are looking at, we would be looking at the reorder point based on that assumption that the distribution is normally distributed. That would be the mean demand during the lead time plus Z alpha, alpha being the service level defined here, Z being the Z score, you all know that, and sigma L would be the demand variation during the lead time. L here is representing the lead time. So what do we have? We have this scenario, let's say normally distributed with mean of 192, this is the average demand. 1 minus alpha will be the service level, so alpha would also, we can call alpha the level of rejection, what you say, or the probability that you will have the stockout. So 1 minus alpha would be the service level, the probability that there will be no stockout. So if you see that service level would be the probability that demand during the lead time would be less than the reorder point, which is equal to 1 minus alpha. And if you see the right hand side of the tail, there is a probability, or there are chances given by R, that probability during the lead time is greater than the reorder point, which we called alpha. Alpha would be the probability that you will see a stockout. And we can actually have this derivation. We are not going towards that derivation, but the thing is, the end result would be that reorder point will be the sum of the mean demand during the lead time and the product of Z alpha into the variation or sigma lead time. We actually assume that lead time during lead time demand is normally distributed, and estimation of the normal distribution parameters is actually possible. So you can actually estimate. It's not the prediction, it's the estimation. So this is based on the forecasted demand. Historical data would be available with you so that you can find out the mean demand during the lead time as well as the variation in it. So let us take an example. Estimation of the mean for some enterprise, the weekly demand is 10 weeks, average demand is 120 juicers per week. And estimation of the variance of the weekly demand is, sample variance is, let's say, 83.33 juices. That is the variation which could happen in 1 week. So what do we have? We have to find out the mean demand during the lead time and the sigma L, which is the variation during that lead time. it has to be adjusted because since the lead time is longer than 1 week. So what happens, the lead time is, let's say 8 days, and you work for 1 week, 5 days a week. So it would be 8 by 5, which will be equal to 1.6 weeks. So this would be the lead time. So lead time is more than 1 week. How can you actually translate into weeks? Just 5 working days, 8 would be your lead time. So 8 divided by 5 will actually give you 1.6 weeks. This is the lead time for your order. Estimate for the lead time, mean demand and variance of demand would be, that is 1.6 into 120. 120 was the demand for 1 week. Now you multiply it with the lead time. It is 192, and the variation in it would be 1.6 into the variation, which is given as 83.33 juicers. So the variation becomes 133.33 during the lead time. So this is the variance during the lead time, and this is the mean during the lead time. Then the current reorder point, if you can remember in that example of AAC appliances, the current reordering policy was at 205. I'm just taking it as a reference point here. So that means if your level reaches to 205, you will order again. So what will happen? Your mean mu L would be 192 plus Z sigma L. So that is Z into 11. That is, how come you get 11.55? This is the under root of sigma square L. Actually, the variance is given there. So you need to translate it into the standard deviation because we need sigma L in the formula. So what will happen? 133.33, you take the under root of it, it will become 11.55. So you have 1.13. So for normal distribution table, you can get the Z-score table. This will actually give you, for 205 juices, this value of Z, which is 1.13 here. If you look at the normal distribution table, it will translate into 87% cycle service level. So the management wants to improve the cycle service level to 99%. Now, according to their current policy, it is 87%. The value of Z is 1.13, which corresponds to 87% cycle service level from the normal distribution table. So the corresponding Z value, if you want to go for 99%, then you should have the Z value corresponding to 1% right hand tail is 2.33. What does it mean? It means at 99% service level, that means 1 minus alpha will be 99, so that the value of alpha will be 1%. So 1% value actually in Z table, it actually corresponds to 2.33. So just use 2.33 in the formula. So you have the UL, the mean value, which is 192, plus Z. Now I'm using the value of Z as 2.33, and then you multiply it with sigma L. Sigma L we have calculated before, that is 11.55. So 219 juicers. So you need 219 juicers against 205 juicers, which the management is actually using. This will actually give you the 99% cycle service level. So AAC is willing to run out of stock on average at most 1 cycle per year with the order quantity of 327 juices. What is the equivalent service level for this strategy? Now this is the second question. So what you will do, the total demand for the year was, if you can recall, was 6240. So you divided by the targeted level, which is their ordering level. They are actually going for 327. So it comes out to be 19.08 lead time per year. So likelihood of stock out would be 1 over that 19.08. So it comes out to be 0.0524. 0.0524 is the chances. So it is roughly 5%. So you would say it translates into the service level of 94.76%. You can figure it out. It is 0.0524. It translates into 5.24%. So if you subtract it from 100%, it becomes 94.76%. So cycle service level, enterprises can define their own cycle service level. They can target it, and they can actually check their current policy that what kind of service level they are achieving, cycle service level they are achieving with their current policy. Thank you.